Welcome to Programming with Qt Widgets. In today's episode, we're going to talk about file handling. It's actually a bit more than file handling because most of what you'll see will apply both to files and networks and, well, many things. Let's just jump into it, shall we? The first rule of file handling is to do it with Qt instead of natively, because if you do it via C++, you will have platform differences. Get out of my head. I'm recording. That was Pepe being in my head. I had a long discussion with him recently about where do you cut between C++ and Qt. Do you want Qt to go all the way through your API, all through your C++ code, so that you use Qt all over the place? Or do you want to have a clean C++ backend, and then on top of that, Qt? There are reasons for the latter, that's for sure. Who knows what the next UI technology you want to rely on looks like? Maybe you want something that is completely different from a C++ API, but you can still have a C++ core backend and then whatever the next generation in 20 years technology look like. If you put Qfile in your application, it's going to go really deep down there. But on the other hand, Qfile is a very, very convenient class from Qt, so maybe we should make an exception with Qfile. There are multiple ways that you can use Qfile. You can go and use Qfile directly using read and write to access the bytes of the file, or you can go a bit higher up and use classes like QXML reader or QJSON classes, as we'll see shortly. But when you use Qfile directly or indirectly via those others, what you really often do is that you access a superclass of Qfile, namely QIO device. And that's one of the beauty of Qfile and the whole infrastructure. Let me just go over here and look at the QIO device superclass so you can see the inheritance. First of all, Qfile device, that's a superclass for Qfile. So Qfile is subclassing from Qfile device, which is subclassing from QIO device. But you can see a number of other things. If you want to write directly to memory, then QBuffer, that wraps a Q byte array, which that way you can write stuff just in memory, but with an API that feels like if you were accessing something like a file. We have QProcess. Guess what that is? That's for sub-process communication. We have QNetwork reply, which comes from QNetwork Access Manager, I believe it's called, which is a high-level way of accessing the network. And finally, QAbstract socket if you want to do TCP communication. If you have all your code written against the Qfile API, then all of a sudden communicating over the network using QAbstract socket, most of the methods that you have will actually work because they would be going via the API of QIO device. So let's get back and see what classes are involved here. First of all, the Qfile class itself is, if you open a file, then you create an instance of Qfile and you call open on it, specify whether you want to read or write or append or what you want to do with that file. So that's the access of the file itself. And then if you want to read text from it, there is a class called QTextStream, which is actually streaming text in and out of that class. If you want to do it with data, then surprise, QDataStream. And here's a number of different technologies that Qt has wrappers for. So if you want to read and write XML, then there's QMXL Stream Reader and QMXML Stream Writer. Similar, if you want to do CBOR, then there's QCBOR Stream Reader and QCBOR Stream Writer. And if you want to access JSON, it's slightly different, but still you create your JSON document and then to.json will get you a byte array out of that you can write to your file. Or if you've written in a byte array from your file, then from JSON, and then you have a QJSON document that you can traverse. That's accessing the content of the file. And then there's a number of different classes, at least 3 that I can think of. There's QFileInfo, which will give you information about the file, and there's QDIR and QDIR Iterator for getting you information about content of a directory. We'll see all of these things shortly, except the XML and the CBOR and JSON document. Actually, I'll show you a JSON example, but the others will be in an episode a bit later. But first, let me go in color. This is episode 34. Can you believe that? You've learned quite a bit by now, I hope. But it's not the same as a real in-person class. So why don't you join one of our other, or maybe even this class here, in person, and do a lot of exercises, do a lot of discussion that relates to exactly your domain. And back to the black and white me, who will now tell you about how you read and write from a file. Thank you for that interruption, Jesper. I really needed the break. Reading and writing with the lowest, I would say, level APIs depends on what you want to read or write. First of all, if you just want to read bytes and then afterwards you will handle those bytes yourself, then you can do that using QFile. There's read all, there's read with a maximum length. So read, if you can, 1 kilobyte. And if the end of file is hit before, then of course stop there, but do not read more than that 1 kilobyte or however. And write back again, given a byte array. Byte array. Just taste it, will you? It's an array of byte. What, right? Yeah, an array of bytes. And bytes, that's those things from the ancient history. Just like the stones that you wrote in back in the days. A byte, 4, where did that come from? 8 bits, so 8, 0, or 1 to 1 byte gives you a few different combinations. It is literally just the data read out from the disk. Why am I so much into talking about that? Well, because the other APIs, those that you can access via QTextstream, is reading QStrings, and QStrings read line of QString, and writing, you can do that using streaming operators, actually, operator less than and operator greater than. But they do QString, and a QString is much more than what can be represented in a byte. After all, a byte is 2 to the power of 8 different -1 possibly combinations. Not that many, especially if you take into consideration that there is lots and lots and lots of languages which have many different beyond your typical Latin one. Therefore, when QTextstream read, it needs to know what encoding are we reading from. These days, most of the files are encoded in UTF-8, which is one file format that specifies exactly how that 2 to the power of 32 huge table of characters, how that is laid out. But there are many different encodings, especially historically. So if you need to read some ancient files, you might need to go to QTextstream. If you only always know that you're going to read UTF-8, then you might be getting by with those. Let me show you an example that involves both of these. What we're looking at here now is an amazing, awesome application. Let me just run it for you. See, it's an editor, and I can type stuff in here. Hello world. And I can press save, and I can specify a file that it should be saving to. And it'll even, I can type something in, and I can load that file in again. It is amazing. Now, if I could just find the file, there it is. Hello world. So how did I do the loading and saving? Well, I created a class editor here. My editor is a subclassing from QWidget. You can see I'm using UI files in here. No surprise, hopefully. And here is my editor. I connect the load and save button to load and save methods in my code here. And here are a bit of different code. So first, let's see how I would usually do it if I wanted to just do saving and loading using UTF-8. First of all, here I ask for the file name. We just saw an episode recently where we talked about the getOpenFileName methods here. I create a Q file around this file name, and I test whether I can open it read-only. And if I can open it read-only, or if I can't, then I'll return false, and I will do some error handling here, just printing out I couldn't load it, sorry. Okay, error handling-ish. Then I go to my string, I read all the bytes in, and in this scenario, I assume that I know, because I might be the only one writing those bytes out, or I have a written contract with my customer saying all the files are UTF-8. So I read all the bytes. This will give me a byte array. And then on my QString, we saw that a few episodes back, from UTF-8, get me those bytes into UTF-8 and, well, get me into a QString, assuming that the bytes are encoded in UTF-8. I have a string, I set the string on here. Similar for saving, get me the file name to save, and this time open it in write-only, and whine if not, go to my text edit, ask for the string of the whole text edit, and then file.write, and then write takes a byte array, so I need to take my string and convert it into a byte array where the bytes are encoded by some standards, and this standard here is UTF-8. Let me go up here and just change this one here, so the other part of the code is highlighted. This is if I need to go via some other format, or if I have a format menu in my text editor or something, then I can go to QTextStream and I can say, hey, give me a file here and stream set encoding with this encoding and stream read all. Similar to write out, I can stream and then less than text down here for streaming the whole string out. And I'm not really all that fair to QTextStream because, after all, if I wanted only the different formats, then there are other classes in Qt for helping me with that. But what I can do here with streaming is also that I can stream less than some text, stream less than an integer, stream less than something else, and streaming it back in again. I can also stream greater than instead of just read all. What I'm trying to get to here is that QTextStream is really a class that you do not use all that often anymore, at least these days. Simply go and do what is great out here if you just want to read in UTF-8, which is fortunately now finally the standard in most of File I/O. So this was raw QFile access, or accessing text data using QTextStream. If you have data in there, you can do that using a class called QDataStream. QDataStream is a class where you stream out a number of objects. You can see here out less than blue, out less than color, and that's my QDataStream. And then Qt will take care of writing into the file something that indicates, hey, here's a string. It's going to be 4 characters long, and the characters are blue. Or here is a Q color, and the color is however it represents a Q color. And the cool thing, as I said, did I say that already? Or was that in the previous take? Is that it knows about a lot of Q classes, all of the value classes. So QString, QSize, QRect, all of those things are super easy to stream in and stream out. And it is, however, Qt specific. If you want something that is more generic, that can possibly even work with other applications, then consider CBOR Stream Reader, CBOR Stream Writer. But if you only need somehow to save data in your application, then this might be enough. However, be careful. If you stream out, say, a string, a color, and a rectangle, and then you decide it should be a string, a point, and a rectangle, And so you adapt your application to that. And then you read in the old file. Obviously, it doesn't know how to handle a situation where you're reading in a rectangle from the disk, but it thinks now that you're reading in a point. So you need to have versioning on there. And that's where, personally at least, I found, that is more and more difficult. Maybe I should go with something that is slightly better, like JSON or XML or whatever file format that I want, where I can name the elements that I write out. So we saw how to access files at a very low level, writing and reading bytes out of the file. We saw a bit higher up streaming with QTextStream and QDataStream. And if we move one level higher up now, then we have the XML and CBOR and the JSON, which is file formats that knows how to write objects inside of your, some kind of representation of more structured data. That's what I'm trying to say. Let me give you an example of JSON here. And it's just a simple example. I'll talk more about JSON in a dedicated episode later in this series here. But we start here. QJSON document. That represents a JSON document. So that's the whole JSON file, for example. QJSON object, that's a single object in there. And QJSON value, you're getting the gist of it, right? So film here, and then object insert media film. So now I have an object where it has the tag media and the value film. And I can do a lot of stuff here. And at the end, document set object for that object. And of course, tilde, 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 which is the dot, dot, dot. But, well, something else does that mean here. And at the end, document. Here we are. Document to JSON. Give me your best shot. What does that return? Yes, it returns a qbyte array. And this time, what is the encoding? Well, now it dictates the encoding for to JSON, and from JSON is UTF-8. I create my file here, data.json, file, open, write, blah, 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 blah. So this is how I create my new file, and file, write to JSON. If you go to World Wide Web, well, who calls that anymore, the link below, you'll find all the examples that I have here, and go and look up this example here to get a bit more insight into what does it look like working with JSON. That's not what this episode is about. The key thing here is that I use my Q file to write out this byte array, and the byte array I got from QJSON document to JSON. So that was the first part of working with files, namely the content in the file. The second part is the information about the files. Is this file readable? Which files exist in this directory? And so on and so on. And file path, you can get to them in a number of different ways. Let me just read this slide for you here. You just need to be aware of it. So Q file dialog, we saw that in one of the previous episodes, and you definitely can get file path out of that. You can also go and ask the system about the temporary path. So where is a good place to write temporary files? Where is the home directory for the user? What are the mounted volumes? So which drives are there on my disk? And then there is the more generic QStandard path, which is a way of asking where would be a good place for loading videos, for example, or where do we store audio files, or where is, again, the home directory and the temporary path. You can get those two here out of your QStandard path. It looks like this. Give me a writable location, because sometimes there might be layers in your operating system, conceptually at least. So give me the writable location for where can I write my downloaded files. And that will give you a path to that. And now, once you have a file, you want to know something about it. Does it exist? Well, you have a file name, obviously. You want to rename files, you want to copy files. These are all static methods on QFile. Be aware, copy, of course, is I don't know if it's of course, but copy will block. So put it on a secondary thread if you want to copy without blocking the user interface. But do be sure that you are done with copying before the user get a chance to close your application. But see, the thing about the copy is if you want to copy a gigantic file, then you cannot even update a progress bar unless it is on a secondary thread. Remove or move to trash. And the move to trash is special in that you can give it a pointer to a string that it will fill out what exactly is the path to that file in the trash bin. Why doesn't it just return that? Well, because it returns a Boolean, as do all of these methods here, telling whether the operation succeeded or not. If you want to get path components out of a file, then you will be using qFileInfo for that. qFileInfo absolute path. So if we have this /temp/test.txt, then the absolute path, that is a temp. The file name is text. Who named it? It's not text. It's test.txt. And finally, the suffix is text. You can also, using qFileInfo, get information about, is the file readable? When was it written? When was it read? And many, many other things. If you get a file somewhere, you might need to open that file. And if you're implementing a desktop system, this slide is definitely for you. Might otherwise not be that interesting. But there is this concept of MIME data. And a MIME data is a tag associated with a type, with a file, telling that this file is image JPEG, or this file is whatever video format /MP4. And that is what the QMIME database will help you with. You can go and ask for MIME type for data. So you have some data. What is the MIME types? That will give you the image JPEG, for example, or an IO device. See, that's the file superclass IO device there. Or a string with just a file name. So can I, out of the file name, guess? So if it's end in .mp4, then sure, I can guess that, and so on. Once I have an instance of all of these returns you a class QMIME type. Once I have one of these, I can go and ask for the name of that MIME type as a string. I can go and ask whether it inherits another MIME type, so there's a hierarchy among MIME types. And finally, I can go and get information about what would be the patterns to look for this MIME type. So if I, for example, have the MIME type for text/JPEG, then .star.jpg or star.jpeg might be what global patterns returns. And now I've waited with the best for last, namely two classes, qTemporaryFile and qSaveFile. And you might get an idea of what it is. But if you want to write into a file, then you can go and create an instance of qTemporaryFile, open it, and write whatever you want to do. And this is to avoid a race condition where you say, let me go with file named ABC123, and some other instance or an evil hacker might come and say, I'll just create that file just when you're about to write and get you a buffer overrun or whatever in your application. qTemporaryFile creates a temporary file for you, and you can then use that, save it and move it and what you need to do later on. qSaveFile, you should be using that every time when you create a file with writable. I'll definitely go and check my application for that, because what that helps you with is, and especially configuration files are so brittle. You have all this data in your configuration file, and then you save it, but you run out of disk just before, or there's a bad block or whatever, and the Qt will notice, but it's too late because it already opened your file and wrote into it. The solution is to replace your Q file with qSaveFile, and then qSaveFile colors that. That's obviously my settings file here, and I'm opening it write only. I am writing the color, and this is just my API that is in my brain for what I will save here. And then I'll say save file commit which will test whether it actually succeeded. And if it did not succeed, nothing bad happened, because what the save file mechanism will do is that it will open a complete new file and write everything into that new file, and only when you write commit will it move that old file in place of the new file. And the final part about files and directories and whatnot is the actual content of directories. Which files do I have in there? And you can do that in two different ways. You can create an instance of qdir and go to that qdir and say, hey, give me all the files matching star.txt. It'll give you a list of those back, and then you can traverse through them, which works fine. But if you want to traverse a whole directory structure, then, and possibly even stop, not all the way through, what you want instead is a qdir iterator instead, which is like an iterator. It has a really weird API. It was written in the days when Trolltech were flirting with Java, I'm sure, because it feels more like a Java iterator than what we are used to in iterating here. But in any case, you create your iterator, go into subdirectories, this is what you tell it here, and now, as long as I have more, give me the next file, and then you can, on your dir, access information about that file. And that's it for this episode talking about file I/O. I admit it was at times somewhat just reading up the API, but at least it gave you an idea of what is in there. I will, however, promise you that I'm not just reading up the API in the next episode, because in the next episode, we'll talk about one of the very important classes in Qt, namely QVariant. Until then, have a great time.